equals 3x minus 5.
Nationwide is so much more than a great insurance company. They're one of America's largest financial services companies. Like how I'm more than just Peyton Manning. I'm also motivating Manning. When I say insurance, you say financial services. Insurance.
Yeah, let's not do that. Okay, so let's get rid of that. So for this one, I picked 0, 1, and negative 1. So my first equation, y equals 3 times 0 minus 5. And then I would just simplify that. 3 times 0 is 0. And 0 minus 5 is just minus 5. So y would equal minus 5. So that would be my first point, 0, negative 5. And then I'd put, say, 1 in there. So y equals 3 times 1 minus 5. Well, 3 times 1 is just 3. 3 minus 5 is negative 2. You know, if you got a number and then when you're just subtracting and the second number is bigger, you're going to end up with a negative. So 3 minus 5 is negative 2. And then last, for this one, I got y equals 3 times a negative 1 minus 5. Well, 3 times negative 1 is negative 3. And so now I got negative 3 minus 5. And what's negative 3 minus 5? Negative 3 minus 5. It's negative 8. So that's how I would do my T-chart to get my points. 0, negative 5, 1, negative 2, negative 1, negative 8. Or I could just work on this, work on the slope-intercept form. I find the intercept, which in this case is 0, negative 5. And then I'd go up 3 over 1, up 3 over 1. Does anybody have any questions about what we're doing to graph our equations? No questions? Okay. All right. We did the first one yesterday. So let's look at number 3 real quick. So what method do you want to use? Do we want to use the slope-intercept or do we want to use the T-chart? And it doesn't matter to me. Okay. So for T-chart, I've got y equals 3x plus 2. So I get to pick my x's. I get to pick whatever those are. So why don't y'all pick some for me? What do we got? We can do 1. What else? 2. Anything else? Okay, 3. How about negative 2 and negative 1? And I'm surprised nobody put 0 in there. So all I'm doing is plugging and chugging. I got 3 times 1 plus 2. Well, 3 times 1 is 3. 3 plus 2 is 5. Then I got 2. 3 times 2 plus 2. Well, 3 times 2 is 6. 6 plus 2 is 8. Then I got 3. That's 3 times 3 plus 2. 3 times 3 is 9. 9 plus 2 is 11. And then I got negative 2. So that's 3 times a negative 2 plus 2. Well, what's 3 times negative 2? That's negative 6. Negative 6 plus 2. So a negative 6 and a positive 2, that means we subtract. 6 minus 2 is 4. And because my bigger number is negative, it's going to be a negative 4. And then finally, if I put in 1, I got 3 times a negative 1 plus 2. What's 3 times a negative 1? That's negative 3. Negative 3 plus 2 is what? Negative 1. So let's look right here real quick. This is probably a mistake because I don't think we got room on our graph for it. That's one thing you got to remember is when you're doing the T-chart, you got to make sure that the numbers you pick are going to fit on there. Let's see, we got 1, 2, 3, 4, 5, 6, 7. It goes from negative 7 to 7. So this one technically is not going to help me either because that goes further than 7. So let's graph the ones that we got right here. We got 1, 5, negative 2, negative 4, and negative 1, negative 1. So 1, 1, 2, 3, 4, 5. And then we got negative 2, 1, 2, 3, 4. And then we got negative 1, negative 1. So we want to connect those points. Right? Now, this right here isn't really in a form that we've worked with a lot. So the first thing we're going to do is change it. We're going to isolate the y. So what do I do first to isolate the y? Not exactly. I'm going to subtract 6x because I want to isolate this thing. So I got to get rid of this, then I got to get rid of that too. So first, I'm going to just subtract 6x from both sides. So that's going to give me negative 2y equals negative 6x minus 4. Now notice I didn't add them together. I didn't get negative 10x because they're not like terms. I can't combine them. That's like trying to add an apple and an orange. They're not the same. So I can't do that. But what I can do next is I'm trying to isolate y. What do you think I need to do next if I'm trying to isolate y? And does everybody understand what I mean when I say isolate y? I'm trying to get y by itself. I'm trying to get rid of everything else on one side except for y. So I got negative 2y equals negative 6x minus 4. Does anybody got any ideas? What's my next step? Okay. I'm going to divide by negative 2 on both sides because this is negative 2 times y. And if I'm trying to get y by itself, I do the opposite of what's going on. And that's negative 2 times y. A letter next to a number is multiplication. So I'm going to divide by negative 2 on both sides. So those two things cancel out, and I got my y. What's negative 6 divided by negative 2? Positive 3. So that's going to be 3x, and then I've got negative 4 divided by negative 2. Positive 2. So that's what I'm going to work with. Oh, wait a minute. Do you see anything strange about that? Look at the problem. You see anything that's weird about that? Okay, I guess not. All right, so let's graph it. All right, give me some numbers. About 1 and negative 2 and negative 1. About 2 and 3. They're the same equation. They're the exact same equation. If you take an equation and you multiply it by a number, just because it looks a little different, it's still the same equation if you break it down. So if I plug in 1, I'm going to get 5. If I plug in negative 2, I'm going to get negative 4. If I plug in negative 1, I'm going to get negative 1. If I plug in 2, I'm going to get 8. If I plug in 3, I'm going to get 11. So what ends up happening here? I'm going to get two lines that perfectly overlap. So what do you think it means if my lines perfectly overlap? Actually, it's just the opposite. But that was good thinking. What we would say is that the answer to this system is infinitely many solutions. Because what is the answer to one of these problems? Well, let's go back up to the first one just so we can talk about it for a second. I'm going to have two or more lines. I want to see where those lines cross. Where do they touch? And so in this case, these two lines touch at -3, 1. So there's one solution. -3 for x, 1 for y. That's my solution. But these two lines, they perfectly overlap. So every dot that's on one line is on that other line. That means if I'm trying to find out where do they cross at every point. Every point on the line crosses the other line. Does everybody understand what I mean? I mean, okay, do y'all understand what I mean? Because these lines overlap. Every point on the first line touches every point on the second line. So there's infinitely many solutions. There's too many to count. You could say infinite solutions. You could say infinity if you want to, but that's what that means. When I have two equations that when I break them down, they look exactly the same, then the answer to the problem is infinitely many. It's like, how many times do they touch? They touch an infinite amount because a line is just a group of infinite points. Anybody got any questions on that? You got two lines that overlap. Now, that's two out of the three things that we could get. We got where we got 1 point. We got where we got lines that overlap perfectly. And so we got infinitely many points. There's one more type of solution that we can find. And let's see if we get to that. But first, let's mess around with this second one. Excuse me. So, did you guys do slope or did you guys do T-chart for number 2? Okay, slope. Now, in my opinion, the slope seems easier, but that's just my opinion. So let's look at the first equation. Y equals -x plus 3. What's my slope for that? Not 1, but no, you was right there, but -1. You know, if there's no number in front of your x, it's a 1. But then if there's a negative in front, then it's a -1. So what's my y-intercept? 3. So that means the first point that I got is 0, 3. So that's what I'm going to do, is do that. I'm going to start at the origin, which is the center, and go 0, which means I don't move left or right. I just move up or down. And it says 3, so I go 1, 2, 3. So that's the first point for my line. The slope is -1. That means it's either -1 over 1 or it's 1 over -1. Does anybody have any questions on how I got those two things? Does anybody have any questions on it? A -1 means I'm gonna have a negative divided by a positive, and it doesn't matter which way I do it. It doesn't matter if the negative's on top or on bottom. But what that does for us is if I start with this one, I'm going down 1 unit and 10 to the right 1 unit. So down and to the right, 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 down to the right. That's what this one does. If I start with the negative being on the bottom, this says that I go up 1 unit and then to the left 1 unit. So I go back to my original point right here, which is 0, 3, and I go up and in to the left, up and to the left, up and to the left, up and to the left. And that's my first line. Ooh, that was kind of bad. I don't have to graph all those points. You really only need 3 points to graph a line. Okay, so that's my first line. And then let's get the second one. So we got y equals 2x minus 6. So what's the slope for that one? It's 2. And then what's the y-intercept? -6. So that tells me that my first point is 0, -6. So 0, start right here, and then go 1, 2, 3, 4, 5, 6. So that's 0, -6. And now what does our slope tell us? Well, if the slope is 2, that means I'm looking at 2 over 1 or negative 2 over negative 1. Does everybody understand why I can do this? I can say 2 over 1 because I can just smack a 1 under it. Or if I'm thinking 2 over 1, a negative divided by a negative is a positive. So I'm okay putting negative on both of those because they cancel each other out anyway. So now let's do some of this. So this first one says I go up 2 units and then to the right 1 unit. So up 2, 1 to the right. 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 Anybody have any questions on that? Okay. That other one's not yours. The other one is from my calc class. Okay. So I got my 2 lines. And now I'm just looking for the point to where they come together, where they touch. And that looks to be this point right here. Right here. And so that point looks to be 1, 2, 3. So that point is 3, 0. Because it stays on the x-axis, it doesn't go up or down, it's 3, 0. Does anybody have any questions on 1, 2, or 3? No questions? Okay, let's do one more and then we'll call this. Okay. Let's see. Let's look at number 5. Now, number 5, both of my equations don't look how we're used to them looking. So we want to isolate y. So let's start with the second one. I got x minus 2y equals 6. What's the first thing I should do? Yep. So what step do I need to take first to get y by itself? Not exactly. I'm going to take x and I'm going to subtract x from both sides because I want to get y by itself. So the first thing I'm going to do is get rid of the x. So subtract x from both sides. This knocks that out. So now that's no longer there. So I got negative 2y equals. And so then here, I got negative x and I got 6. They're not like terms, so I just write them down. Negative x plus 6. And then what's the next thing that I need to do? Divide by negative 2 because I want to get y by itself. And this is negative 2 times y. I just want y. So I'm going to divide by negative 2 on both sides. So, and these two things cancel each other out. So that's going to be y equals, and then negative x divided by negative 2. Well, the negatives cancel each other out. And I'm just going to have x over 2. And then I've got 6 divided by negative 2. What's 6 divided by negative 2? Negative 3. So that's what I got. Let's see what happens when I do this. I got negative 2x plus 4y equals 12. So I want to isolate y. What's the first thing I need to do? I need to get rid of negative 2x. So to get rid of negative 2x, I'm going to add 2x to both sides. Right? So I do that. and this goes away. So now I got 4y equals, these are not like terms, I can't combine them. So that's going to be 2x plus 12. 2x plus 12. And so then what's the next thing I'm going to do? Well, next thing I'm going to do is what? Divide by what? Divide by 4 on both sides. So if I divide by 4 here, on this side, the 4's go away. So that's just y equals. And now I got 2x divided by 4. 2x divided by 4. And then I've got 12 divided by 4. What's 12 divided by 4? 3. What's 2 over 4? Can I do anything with that? Two over 4. Nothing sticks out to you about that? I can divide by 2 or reduce this thing by 2. So if I divide by 2 on the top, I get 1. 4 divided by 2 is 2. So I end up getting x over 2. So here's what I got now. I got that equation, and I got this equation. Whoa, that was a little too much. Does anything stick out to you about those two equations? Say it again. Yep, they're almost exactly the same. The y-intercept is a little different. The thing that's crazy about this one is that the slopes are the same. So let's graph it with slope. X over 2 is the same as 1/2 times x. So the slope is 1/2. 1/2 x minus 3. So what's my y-intercept for this one? Right here, the y-intercept is -3. So if my y-intercept is -3, that means the first point I got is 0, -3. So that's what we're going to start with. 0, 1, 2, 3, right there. And so my slope is 1 over 2. Rise over run. So I go up 1 unit and then to the right 2. Up 1 unit to the right 2. Up 1 unit to the right 2. Up 1 unit to the right 2. And then I can do the opposite. I can do a -1 over -2. So that's go down 1 unit and then go to the left 2. Go down 1 unit, then to the left 2. Down 1 unit and then to the left 2. So that's my line right there. And then let's graph this one. All right, so I got y equals 1/2 x plus 3. What's my y-intercept? It's +3. So that means the first point I'm looking at is 0, 3. So 0, 3 puts me right here. And so now I'm going up 1 unit and then to the right 2 units. So up 1, 2, up 1, 1, 2, up 1, 1, 2. And then I can do the opposite. I can do -1 over -2. So that's down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. Wait a minute. What's going on here, Ferg? This is that third situation I told you about. So there's 3 different situations you can get when you're graphing systems of equations. You can find a point, just like we found a point right here on these first 2. You can find 2 lines that overlap perfectly. So then it's all solutions. It's all of them. Or you can find 2 lines that do what these do and they never touch. like if you look at this brick pattern on the wall. This line right here, that line right there, they're parallel. They never touch. They just go on forever. They go all the way around the room, but they never touch. Well, the same for these. If you have two lines that have the same slope but different y-intercepts, they're parallel lines. Because what's the slope? The slope tells you how steep your line is. And if your lines got the same amount of steepness, but they just start at a different point, then they're going to be parallel. And so these, they never touch, so there's no solution. All right, no slow. Yep. So there's no solution. Does anybody have any questions on that? So there's either 1 point, 1 answer, infinitely many answers, or no answers. Those are my three options for when I'm graphing systems of linear equations. No answers, 1 answer, infinitely many answers. So if you pay attention to the slopes and the y-intercepts, they can kind of tell you in most cases what kind of problem you got. If the slopes are the same but the y-intercepts are different, they're parallel. If the two equations are exactly the same, then you've got infinitely many solutions because they're the same line, they just overlap. And then if you don't got either of those situations, then you've got just 1 point. Okay, so before I end this, does anybody got any questions on any one of those problems? Nobody's got any questions? Okie dokie.